Alright, welcome to your first actual flipped lesson that's related to a physics concept. Just some reminders. Remember, part of your portfolio grade is, and that relates to your homework grade in the grade book, is bringing notes to class tomorrow. Okay, so make sure you have those with you. This video starts out with a lot of information, definitions, that sort of thing. Write down some examples. The second video gets into some more application to the ideas, so you might want to write down like how you add certain things. Alright, and then make sure you do the online form, the Google form, the little questionnaire, just to see how well you guys are understanding, and then keep in mind that you will have an open note mini quiz tomorrow on the video. So, welcome to Scalars versus Vectors, your first physics topic. In physics, we work with a lot of quantities, and scientists define them in two different ways. They are scalars or vectors. Alright? And quantities we work with are things like 12 seconds, 5 meters, 100 miles, alright? 56 meters per second east. Alright? So, these quantities can give you just a size or a magnitude, right? Which is just going to be something very, very simple. It will be a number with the unit that number is measured in. Alright, so like 5 by itself really holds no meaning. What is it? 5 seconds? 5 degrees? 5 inches? Okay, so scalars need just a number and a unit. Right? Whereas vectors start with the size or the magnitude, but we also add a direction to it. Alright, so this is going to have a number, a unit, and a direction. Okay, so let's get into that with that. So again, scalar has size or magnitude only. An example of this is I walked 5 meters. Okay, or the table is 5 meters long, or the room is 6 meters high. Okay, things that don't necessarily need a direction, or the direction is irrelevant. Alright, so try to come up with some more examples, if you can. So try to think about things. I know that talking about distances can be a little misleading, but try to think of some units that have absolutely no direction whatsoever. Alright, so give yourself a second to think about those. Maybe pause the video. Alright, but I'm hoping some stuff that you're thinking of are, going with this example, you could go with some more distances like 12 miles, alright, or any sort of length. But also say time. Does time have a direction? Until we figure out time travel, no, it does not. Okay? Time always goes forward, so we don't need to imply a direction. There's no negative time, there's no backwards time. Okay? So time is scalar. What else can you think of? Hopefully you might have thought of maybe temperature. Okay? Your body temperature is 98.6 degrees Fahrenheit. It's not 98.6 degrees Fahrenheit north, it's 98.6 degrees Fahrenheit. So that's another scalar quantity. Okay? So vectors, however, have a magnitude and they imply a direction. Okay? So you can say that you walked 5 meters north, or left, or south, or east. Alright? You can even go positive directions or negative directions based on like a grid. Okay? So we'll try to come up with some other ones. Okay. Easy things are to stick with lengths again. So you can do, instead of 5 meters, you can do 5 inches. You can do 12 millimeters. Okay? Anything like that. But some other things that are vectors that you might not think of right away, and we will eventually work with, are things like velocity, which is like meters per second north. Okay? Acceleration has to have a direction. So you're accelerating at 5 meters per second squared south. Right? Or forces, right? You have to push something or pull something in a particular direction. Okay? So those are the sorts of vectors that we'll be dealing with. Now, let's talk more about these vectors. Because vectors have more than just a magnitude, you have to represent them very specifically. Okay? So, if you're talking about 5 meters, just drawing to scale a 5-meter line is sufficient. But because vectors have a direction, you also have to indicate that direction. So that's why we use an arrow, right? The arrow, the head of the arrow, indicates the direction that magnitude is going. Okay? Could be 5 meters, could be 5 meters per second, could be 60 meters per second squared, could be 500 newtons. Alright? The arrow will let you know if it's going up, down, north, south, east, west, whatever direction you're dealing with. Okay? Speaking of directions, different ways we can talk about directions. We're going to focus on the cardinal coordinates to start with. Alright? But then we're also going to, there's times where north-south doesn't necessarily apply. You know, if you kind of think about the fact that you're not really moving stuff more than a couple of inches, north-south doesn't quite matter, but maybe up-down, left-right matters, okay? But the cardinal coordinates, just make sure you remember how this looks. North is up, south is down, east is to the right, west is to the left, alright? Hopefully this is just a review and you guys already know that. Your Cartesian coordinates, however, is if, say, you're moving an object along a grid, okay? So if you start in the center and your object moves here, alright, that would be a positive movement. Whereas if, say, instead you start in the center and the object moves to the left, that would be a negative movement. Down would be a negative movement. Okay, so left and down is negative, whereas right and up is positive. Okay? Keep this in mind. It will eventually come up in some limited practice this time, and especially as we start getting into some more complicated units other than distances in the coming weeks. So, here is just a little bit of practice before you have to actually submit something that's going to be graded. So I suggest pause the video, try answering this on your own before I re-go over it, and then start the video back up because I'm going to start explaining the answers. Okay? So, if you gave an example of a scalar quantity, it needs to be any quantity that has just a magnitude. Okay? And remember, a magnitude is a number and a unit. Number and a unit. Alright? The units don't imply being a vector. Vectors have units too. Alright? Whereas a vector quantity should have said something that has a magnitude, so a number and a unit, plus a direction. Okay? So my examples in here, and there's tons of examples for this. So it's pretty easy just when you're having to come up with your own, you can go be really easy and go 5 meters and then 5 meters east. Okay? And then magnitude, drawing a vector that shows magnitude to the west. Your length can be any length because you weren't given a specific magnitude, but the key thing was that you have to have the arrow pointing left or to the west. Okay? So that's the end of the video. Make sure you fill out the form. Well, you have to continue and watch the next video and then fill out the form. And then make sure you have your notes with you in class tomorrow. See you then.